Welcome everyone. Now we should start solving the question on the board. The question of the day is there. It says a current of 4 ampere passes through a stressful solution for 20 minutes. Volume of hydrogen at STP is option A 0.56 dm cube, option B 1.12 dm cube, option C 2.24 dm cube, option D 4.48 dm cube. Now solve it and get your answer ASAP. Start solving, boys, now. Start solving now. Hello everyone, can you hear me? I'm not if you can hear me, please. If you can hear me, kindly confirm, please. Hello? Okay, you can hear me, right? Good. Now let's start solving. I'm waiting for you guys' answer. So let's start solving, please. Start solving, start solving. Drop your answer, start solving. You have 7 more minutes to solve. 7 more minutes. By 9:15, we start officially. How many of us have gotten the answer? We have 7 more minutes. Is it 7 or 6 more minutes? Let's ask you. 6 more minutes. Six more minutes. One more minute. I think we're all done, right? Yeah. The thing is, I made a mistake with the portrait. I don't know what to do with the link. Hello, can you guys hear me? I'm trying to. I don't know. It seems I made a mistake. Huh? I made a mistake when I was setting the scheduling, and it seems I've made what is it called? I've put the session in portrait mode. So we might have to like start again if we want the live session to be in landscape mode. What do you guys have to say about that? Are you okay with it being in portrait mode like this? Are you okay with it? Can you drop in the comment section? Are you okay with it, should we um or should we restart the live session and what is it called? Should we restart the live session and make it landscape? What do you guys have to say about it? Kindly respond in the comment section ASAP so we get this thing started. Be fast, please. Okay, if you guys say we should leave it this way, then I'll go by your statements because My second phone is not actually even kickstarting for me to actually check how it's appearing over there. That's why I'm asking for your opinion. But nevertheless, my voice is cracked today, right? We just have to manage. But nevertheless, we'll just get the stuff started. So, I think it's time we smash into what is it called? Electrolysis now. Let me check it again if it's a work now, so I can actually see your comments. Yeah, and then we'll start. This is almost 9. This is almost 9:20, or is it 9:20 already? And this question on the board, how do you solve it? How many of you drop an answer? Some of you dropped C. Next question. C. Right, okay, let me start. Now, please. Okay, I think it's okay. That's true. You're right. But let me sit down. Can you guys see me when I sit down? Can you see me so that my legs are actually very weak? My legs are so weak. I ain't gonna lie to you, man. Okay, I think it's clear, right? Beautiful. This making sense. Yeah, it's all right. I prefer it this way now. So let's do it this way. Huh? Let's do it this way. Now, how many of us are actually active? You're active. Welcome to today's live session. I think the live session is starting right now. Yeah, which planets? Rashid Khanna, whatever you say. The quantum navigators are currently 2027. So I don't know for you, though. I don't know for you. Okay, let me see. How many navigators are here? So I want to see if you're a navigator. I just what I want you guys to do is this. Just write it there. Navigator, doctor, whoever you are. Just say navigator, nurse, and your name. Let's get it started. I want you guys to drop your name. So I welcome everybody to today's live session. So I'll start from me. I have navigator Tutor Nelson. Yeah. So drop yours. Let me see my quantum navigators. ASAP. Drop it. Drop it. However, this question we're not solving it now, but the answer is A. So that's the answer. But before we do that, drop me. Yeah, I see you, Abdul Malik, doctor. I see you, Abdul Malik. I see you. I see you. Bring it up, boys. I want to see your names. I want to see your profession. I want to see your name. I want to see your profession. So let's make it fast. Let's make it fast. I want to see your name. I want to see your profession. ASAP. It's all right. I think I can see a few ones that we're receiving airtime today. Yeah, young Mike, what to study? I actually can't see it there. If it's medicine, if it's computer science, if it's nursing, if it's engineering, what's your course? Yeah, I see your own Dr. Jesu Tomisi. I see your own doc, actually. Yeah, put the name there, man. Follow instruction. Yeah, okay. Medical practitioner. There's nothing like that, so I don't know you. Um, okay, yeah, Dr. Docas, I see you, Barrister Miami, I see you, Dr. Wigan, can I see you? I think welcome to today's session. So let's just get this thing started and kill the ones and for all, boys. You ready for this? Now this is where we start from, huh? And this is how we do it today. Just in a very simple way. This is how we do it today. Now, so once again, the last thing we're doing before I dive into the derivation and get some derivation into this shit. That is what I want to do. So I want to write something on this board. You're going to take a screenshot, then attach it to the link of our live session and share it to your friends, share it to your status right now. Electrolysis live on YouTube. Now, at Nelson Learning Space. So you're gonna take a screenshot of this. I'm waiting for you. So take a screenshot of this and drop it right now on your WhatsApp status. Drop it on to your friends. Attach it to the link of this live session. Do it now. Take a screenshot right now. Take a screenshot. I think I'm there. They can see my face. I don't know. They can see that the person taking this electrolysis is like Tinubu. So take a screenshot right now and share it to your status. Share it to your friends. Share it to those that need this topic. That need this subject. Jam bites. People that are preparing for work. Anyone. Secondary school student. Share it right now, boss. Boys, share it right now. I trust you guys to do it for me. Start sharing it now. Share it right now, boys, so before we get started. Are you ready? I think we have done this, right? Thank you so much for doing that. Thank you so much for doing that. Take a screenshot of this and share it. And then, this is going to be massive today. Jesus, this is beautiful. Okay, I think we're done with this now, so let's get started, boys. Now, in our last live session under electrolysis, we treated or we treat our introduction to electrolysis, right? We talked about what this word actually means, electrolysis. And electrolysis is not it's not a word from Greek or a word from Rome or a special word. No, it's just a word basically from what? Electricity, and lysis. What does lysis mean? Which means what? The breakdown. So basically, we can also say that electrolysis is just the process where we use electricity to cause a what? To cause a chemical change. And then we will talk about the cathode and the anode. So today, we want to be going deep into electrolysis of some substances and what to be yielded or what's going to be yielded at the anode and the cathode side. So I think we'll start from where we stopped last class. So I believe that everyone currently on this live session, thank you, Jesu Tofume, Jesu Tomi Sikorede. Thank you, Orelapa Malik. Thank you for being here, and thank you for actually sharing that with whoever you share it with. Thank you. So I want to be doing electrolysis of some substance, some special substance that comes out in most exams for the secondary school level or the high school level. So let's start with the one we did last time. Let's do it again today, which is electrolysis. Which is electrolysis of what is it called? Electrolysis of molten NaCl. I'm going to see you guys comments again because I'm actually dropping my phone right now. So I want to go basically more like going ghost mode on this thing. So let's do it. Electrolysis of molten sodium chloride. Electrolysis of molten NaCl. Now, on a very simple instance now, something I want to tell you is this. There are two core words, like you already understand what's electrolysis. Just the chemical decomposition of a compound, either in molten form or aqueous form. That's aqueous solution now. So there are two words that are very important to understand when dealing with non-calculation question electrolysis. What does molten means? And what aqueous means? Now, basically, these two guys are both in liquid format. They are what? They are both in liquid format. Just that their liquid was gotten from different angles. You see, this guy here was gotten as a liquid when we turn the solid to liquid using heat. So this one's gotten through heat format. That's plus heat. When it's gotten was through water format. That's plus water. So sorry. When you add heat to a substance and it turns to liquid, we call it molten. For example, molten NaCl now was an NaCl that is a salt, a common salt that was turned into a liquid format or liquid form using what? Heat. While aqueous NaCl was an NaCl that is turned into a liquid NaCl by the what? By the addition of what? Of heat. So now scenario now, when we're doing molten NaCl once again today. Now the thing here is this, after you understand this part, so which means a molten, let's say we have a molten XY, this is a compound. It means this compound is a load, nothing is mixed with it. It's just that it's in liquid format, but only this compound. But if you have aqueous XY, which can also be written as what? As XY aqueous underneath. This means that what? This means that this substance here contains water. Do you get the point here? It contains water. Now, if you ever understand that part again, this is the first thing I'll explain today. 1 copper. This is another 10, 2 copper. Are you following something here? Are you following something here? Now, bring it down to this place now. So we're going to do molten NaCl. There are two, I am going to be drawing the electrolytic cell for the electrolysis of molten NaCl. But what I'm going to let you know is that two things will happen. Something will happen at the anode side, which is what we call the anodic half reaction. The anodic half reaction. Now something will happen at this anode. Now, before we do that, I'm going to do something here. There's something that will happen at the what? At the cathode, which is what? The cathodic half reaction. Copy? Good. Let's continue. Let me see. Is there any comment? Like I said, I'm not on my phone again. Are you following, please? Oh, somebody have a question. Oh, sorry, I wasn't seeing your message earlier. So I'm going to scroll up now and see if there's any question, please. Okay, let me stop here. Okay, real boat here. Real boat, Jesus lover. What's the question, please? Why continue? I'm just coming to the screen now. What's the question, please? Yes, if you be fast, boy. You have less than 10 seconds more to ask me the question you want to ask me, boy. What's the question? So I get to attend to it and then we'll continue what I'm explaining. Is the question coming or not? What are we going to what are we going to put for molten state? What does that mean? I don't understand. What does that mean? Rephrase your question to make it clear, please. I don't understand. Idera, welcome. Idera F2S, welcome. I don't understand the question. Please, robot. Heat for molten. Is that what he's asking? Are Daytona Fikayomi? No. Okay, I see 2 questions now. You know, that's for aqueous state. We put AQ at the bottom side. Oh, is that what you meant? Oh, next time make a question explicit. Make it easy to understand for us. We ain't AI. We are humans, huh? Okay, I think I understand your question now. Yeah, I see your question. I did on Afrikayami. I'm going to explain it right now. Please, if you are here, subscribe to the YouTube channel, to your friends and families. Share the link to your friends and families. Share it to your goats. Share it to your dog. Share it to everyone that needs this. So, if you're writing XY as the compound, we don't have anything here because in this place, in the subscript, there are only 3 things that can be written at this, 3 or 4 things that can be written at the subscript. Number 1, liquid. Number 2, gas. Number 3, solid. And number 4, aqueous. So for molten, you write it here, it starts as a prefix, not as a subscript. Let me say it again. If it's a molten compound, you only write it as a prefix, not as a subscript. You get? Now, let me see Fikami question. Fikami said, answer the question, is molten same as concentrated? Come, stop that. Don't say it. Don't let anybody hear you. No. Molten is not the same thing as concentrated. In fact, the word concentrated, actually, if you step leg out of chemistry, I want to explain concentrated. Concentrated does basically mean you mix 2 things together. But instead of you, like, football or shooter, what about do that? You dissolve A inside B. You dissolve A inside B. Now, the A inside B, if it's too much or if it's plenty, we call it concentrated, meaning the strength of this A is plenty inside B. If the A is small, we call it dilute. Do you understand now? So that's the meaning of concentrated. Like for example now, I want to see something funny example. Yeah, I don't know who are watching me. Let me use a very weird example. Now, in a very small room, and somebody farts. In a simple word, somebody mess, right? That mess now, in a very small room, the mess is said to be concentrated. But if it's an open place or the room is very big or it's a big hall, and your mess is not concentrated. Because in this case, now the mess will spread very fast. By volume, the mess is already diluted. So no, multi cannot work for concentrated. No, concentrated is only or mostly deal with things that was in aqueous form. Copy? Do you understand now, boy? Another question. Question here, oh, I think that's just normal question. Probably. I can't join this. Blah, 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 blah. No question again. Let's continue now. Now, okay, I think I'm done with this place. I think you've jotted it down, right? Now, so you see now, by the time we are doing electricity of NaCl, something's going to happen, right? You see, let's say this is the anode bar, right? This is the anode bar, the anode, which is the positive bar. Then we have the cathode bar, which is what? The positive, negative electrode. Copy? Now, you see, this electrode now, we have NaCl, right? NaCl. So this NaCl will be splitted with the electrolysis. So what happens is this. The NaCl will turn to what? Na plus and Cl minus. The Na plus will go to the negative electrode to come here, and same as to come here, we have Cl minus here, right? So now this thing is this. As I explained in the last electrolysis session, that the electrolytic cell is a complete circuit where electron goes clockwise in a clockwise manner, which means at the end of the day, the cathode is not electron like he loses electron to the cathode, to the anode, the anode, which means this sorry, it doesn't lose this. This cathode here has too much electron. Has what? Too much electron. Let's put it that way. Too much electron. Then anode, because anode electron leaves the electron to the anode. So anode has what? Less electron. Unless it's what? Plenty. Cathode has what? Plenty electron. Plenty electron. Which means cathode is what? Cathode is new taker. New taker. Anode has what? Anode has few or little or small electron. Few electron or few electrons. That should be better. That should be the right word or preferred word. Has few electron, right? Which means what? That means anode is the word. Anode is a new taker. Sorry, old taker. Anode is suffering from what? Sakpa. Do you copy now? So don't forget, the positive ion will go to the negative side. Negative ion will go to what? The positive side. So in that case now, in the anodic, we are doing this one first. The anode. This is the anode, right? And this is the cathode. So in the anode now, we have Cl minus coming to the anode. Coming to do what? What is it coming to do in the anode? What is Cl minus coming to do in the anode? Cl minus is a negatively charged particle. And what does it mean? A negatively charged particle is a particle that has what? That has gained electron. That has received electron. So what is it coming to do here? It's coming here to give out that electron it has gained. Copy. It's coming here to the anode to give out that electron it has received. Meaning, I'm coming. So today, before this today's class, I went to go and collect plenty money from the bank. I went to Access Bank so I can have access. I went to First Bank so that I can be the first. I'm going to show you plenty money now. Plenty money that I've collected today. So like I told you, share this link to your friends, share this link to your classmates, share this link to your classmates, because today we'll be sharing plenty money. Shop my money. You see, can you see money? I have money. You didn't know what's going on. I have money. Ego. So now let's go now. So this is chlorine. Now this is chlorine. Chlorine was zero. No charge particle. No plus, no minus. Chlorine now have this. Chlorine collected this from this guy. I collected this from this guy. So I'm not chlorine now. So chlorine has minus what? 1. Because now I have received. So now, when chlorine came as minus 1, like, oh, I received 1. If I collected, if I had gained 3, I have what? 3 minus or minus 3. If I had gained 4, I have what? 4 minus. If I had gained 5, I have what? 5 minus. Are you following something here? So now, but I only collected, I gained 1, so I'm minus 1. Meaning I'm only basic. Only basic. If you are here, you're not a Nigerian, and you don't understand what Onigbese means. Onigbese means a big man. If you understand me, drop your favorite emoji there. Onigbese means what? A big man. You say a big man if you collect if you're Onigbese. Okay, so don't tell everybody in your school though. Now so chlorine is what? Is just -1. Huh? Now coming now on to the anode. Remember the anode has what? Few electron. The anode is electron deficient. The anode is suffering from lack of electrons. The anode does not have electrons. So it's going here to give out that electron that it collected. Meaning I have this one electron. So I went to the anode. Meaning, okay, anode, you have few electrons. You have take this electron. If you understand, please say right on, sir. Drop it, say right on. Say right on, let me get it, boys. Plenty money. Drop it there, boys. Drop it there, boys. Drop it there, boys. I can see your names. I know my biggest fan right now. I see some of you there. Drop it there, boys. You are with me. Let me know. Are you with me, boys? Drop the reactions. Yeah, thank you so much. I see you, Malik. I see you, Adeze. Yeah. I see you, okay. I see you from oh God. That's my Clef. I think your name is always constant in my class. I'm rooting for you, boy. So now, he went to the anode to what? To give us that one electron he collected. So now you write the equation in the anode. Anode is equal to what? Remember, the anode is SS1, right? This guy has SS1. That will be equal to what? Cl plus E minus. So he has his balance language has given out to 1. I forgot something here. But chlorine is what? Chlorine is a diatomic molecule. So put 2 here. Which means to form Cl2, you need to have 2 Cl here. So 2 Cl here. Now how many electrons here now? 2 times 1, that's 2. So write it here. 2E minus. Do you understand? Do you understand? Do you understand? Now that's how it works. So this is the anodic reaction fraction. So what happens is that chlorine ion went to the anode to gain to give out 2 electrons to become chlorine gas. Which at the end of the day, what happens in the anode is what? Chlorine gas. This gas, which means chlorine gas is liberated. That's what happens in the anode. In the what happens in the anode? Chlorine gas is liberated. Then how many moles of chlorine gas is liberated? You now check the back of chlorine gas. Chlorine gas is Cl2. At the back, everybody that is in the comment section. At the back, what number is there? Is it 1? Is it 2? Is it 3? Remember, in chemistry, when there is nothing, there is 1. So write it there. At the back of Cl2, what number is there? Write it, boys. Yeah, Malik, I see you. I see you, Abdul Malik. You're actually with me. You're the most consistent. Yeah, Doctor, I see your answer. I see your answer, Doctor. At the back of chlorine gas, what number is there, boys? Navigators, what number is there now? I need response, yeah? Okay, I see you now. I see you, Small Clef. I see you, real boots. That's right. So which means the final answer is what? 1 mole of chlorine gas is what? Liberated. Now let's use the same principle to understand the cathode. Now, but don't forget, in the anode, 2 electrons were given off. 2 electrons were given off. So which means in the cathode, 2 electrons will be given off. Now let's do it now. So in the cathode, we have Na plus, sorry. That will be Na plus. Now let me use this money again. Now in chemistry, plus means I have given out. So this is my money, and I gave it out 2. I gave out 2 money, yeah. I gave it to this chair here. Hey Jesus, the chair don't collect the money. I gave it to this chair. Huh? So these 2 now that I gave out to this place, I give to this guy now. These 2 now signify what? I am what? Plus. This share is now minus. So I am plus 2. This guy is -2. But if I give out 1, mean I am what? Plus 1. The share is what? -1. So what does that mean? So Na plus went to the anode, sorry, to the cathode to collect back his money. Because the guy is what? The guy is animal shao. And even though those shao, there's something we can give him money for free. We'll cut our money back. Copy? So in that case now, Na plus will receive his electron back. How many? 1, right? E minus to form what? Na. So this instance here, we'll now go to go and take the anode. How many electron was given was lost or was given off? It was what? 2. So put 2 here to make it balance. So 2 here. In that case, this one will become what? 2. This one will become what? So it will become 2. So in summary, how many moles of sodium was liberated? How many moles? Write it in the comment section. How many moles of sodium was liberated? How many moles? Okay, okay. I see you, Forces Vlogger. Let's just do this one for today. We'll take the topics one by one. Just make sure you subscribe to my YouTube channel and subscribe to my follow my TikTok account, and then we'll take it one by one. We can't do everything at the same time. I don't know if you can hear me. Armed Forces Vlogger. Welcome. This is Nigeria, and we are saying hi to you from Nigeria. So share the link to your people, and we'll do it one by one. Today, let's deal with electrolysis first. We'll take it step by step. Do you understand? If you can hear me, please, I will need a response from you. Thank you so much and welcome. Yes, at the end of the day, 2 moles. Hey, they are taking my marker. Hey, okay, I've seen it. I thought it's you guys. So at the end of the day, 2 moles. Jesus is right. Whoa, exhausted. 2 moles of sodium is what? Is liberated. So now sodium is what? Is liberated. And this is a solution of what? Of the electrolysis of molten NaCl. Do you understand now? I hope you're following. Do we understand? Do we understand now? So at the anode, oxidation occurs. And what's oxidation? There's loss of electron. And at the cathode, what occurs there? What occurs there at the cathode? I want answers, please. What occurs there? What occurs at the cathode? And let's do the half-half reactions. At the cathode, what occurs at the cathode is reduction. Reduction. Okay, so let's do the half cell equation. That will be, so let's do this. So let's use blue. Let's use blue. Half cell equation, right? So that now for the cathode or for the anode, this is the anode. Cl minus equals, Cl minus equals to Cl2, then with the gas here, plus what? 2E minus. And this is what? This is oxidation. Then at the cathode, Na plus 2E minus equals to Na solid. How many Na? 2. So this is what? This is reduction. So overall equation will be what? Na plus 2Na plus 2Cl minus equals to Na 2Na, which is solid, plus Cl2, which is liquid. Sorry, I think I've used up my board, but this is the net equation, or the overall equation. I call it net equation or overall equation. I write it out, please. That's a net equation or overall equation. Civil Service 9140. I actually get your point. We also welcome you to the class, Nelson Learning Space. In this place, chemistry, biology, physics is a baby. We massage it and understand it. Welcoming you too. I think you guys are all different. Is it the same person I responded to earlier? Oh, BJ, I see you. Is that name? If I've not mentioned your name, if I've not welcomed you to the class. No. Civil Service. The chlorine will be diatomic. That's Cl2. The chlorine will be diatomic. So your equation is partially wrong. The last chlorine, put 2 there. Do you understand, Civil Service? Yeah? Change and put 2 there. So I think right one is on the board, so we'll move to the next one. Electrolysis of aqueous NaCl. Daniel, I see you. BJ, yeah, shout out to you, boy. Shout out to you. I see you. So you get, can I have the board now? So now what we just did is we just did electrolysis of what? Electrolysis of the molten compound. Now we are doing electrolysis of, okay, I'm going to rub up the board now. Don't forget, on Friday will be our first biology life class. And that Friday, guess what? Our biology life class is going to be on our TikTok page, or TikTok channel, or TikTok account. So it's going to be massive that day. The first biology, Nelson Space biology life class of this year. And however, it's going to be on TikTok, Nelson Learning Space. So I want you guys to be very, very excited. The date, the topic, the time, the giveaways, the smileys, everything will be beautifully announced before that day. Yep. Now, let's do the next thing now. So, yeah, we're going to be doing what? Electrolysis. We already did. So, we did electrolysis. Electrolysis of molten substances. Right? Then, we also have electrolysis of aqueous substances, or molten compound, aqueous compounds. Let's put it that way. I don't know. Are you there? Should we continue? Should we keep on hitting the target? Yes, TikTok, the first biology class. And what I want to teach, even though you're not a medical student, you need to learn it. I'm contemplating on teaching nervous system. While I explain to you why the brain works the way the brain works. Oh God. I want to teach you what? Why the brain works the way the brain works. So that you understand why you study and you sleep. You understand why you study and you sleep. So now that is going to be massive. Jokes apart. I'm going to show you all the inner parts of the brain: the cerebrum, the cerebellum, the hypothalamus, the thalami. Oh God! Oh Jesus! Oh Jesus! Now listen up, ma. See that Saturday. This is not an advert. This is just me telling you what is possible. You will know why cerebrum controls so many important things in your life. Why the hypothalamus is the reason why you can know you're hungry or you're thirsty. Why the cerebellum is the reason why you can stand, you can take picture, you can post. Why the medulla oblongata control things that immediately stops working, you are actually just a dead human being. Or what makes autistic? What is that thing behind the word autism? Or behind that spectrum called autism? Or how can you even understand OCD and PTSD? Or have you actually seen that some people just, anytime they do some mood things, they'll bring it on mood swings. Why? The brain. I'm going to explain to you, you want to understand the brain in attachment with his other twin brother, the spinal cord. They understand the neurons, the sensory neurons, the motor neurons, and the intermediate neurons, also known as afferent neurons, and some books also call it relay neurons. I'm going to explain that. I will explain each of them, thalami. I'm going to explain the pineal gland, the pituitary gland, how the hormone helps the brain or helps the nervous system to do its job. I'll be seeing all those shit on Saturday, right on our TikTok account. Follow Nelson Learning Space right now. You're seeing this video because it's going to be massive. And trust me, by the time I'm done with your brain will be like, dang, this is massive. You get me now? Well, let's come back to chemistry. Right now, boys. So the choices of what? Of molten electrolyte, and what? Aqueous electrolyte. I'll do something very simpler. Now, you see now, there are two different things. In the molten electrolyte now, we're going to be having just two ions, just one positive ion and one negative ion. You get it? So that means the positive ion will go to what? The anode, the cathode. The negative ion will go to where? The anode. You see now? So this one just vibrates, mostly the metal, and this one vibrates what? Mostly probably the gas. in most cases. In that scenario now, it means that at the end of the day, electrolysis of multi substances, for example, like the way we do NaCl now, NaCl, you already know what will happen, right? The sodium will be liberated in the what? In the cathode, and the will be liberated in what? In the anode. So a good another example now, I think we have Al2O3. So if the electrolysis of this thing, now what will happen? That means Al will come to the where? The cathode, right? Will come to the cathode. No, 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 that was a mistake. Oh Jesus Christ, stop. So Al will come to the. It's correct now. Anode. This is a positive. Oh, sorry, not here. No wonder this is where the mistake come from. So which means at the end of the day, in the cathode, the metal will be liberated. So in the cathode, the metal will be liberated, and mostly in the anode is always mostly the gas. So in that scenario now, so Al2 will be liberated in the anode as metal, then oxygen gas will be liberated at the what? At the anode. So which means maybe you see that I'm actually teaching you the fast way. Look at this thing I just drew now. In electrolysis of multi substances, right? In most cases, except in extremely rare cases that of course it's not your secondary school level or your high school level, it's always what? Just two different ions. The positive ion and the what? The positive ion and the negative ion. Positive ion and negative ion, right? Now in that case, now the positive ion will go to what the cathode, which is mostly what the metal. The negative ion will go to the what the anode, which is mostly what the non-metal, which is mostly in most cases the what the gas. So maybe you see a question that tell you the more electrolysis of a molten substance. Just know this guy is going to the what the metal is going to the what cathode, the metal is going to the what anode, ASAP. The only thing that will now affect the reason why these two guys will not be liberated is the nature of electrode. We're not there yet. But in case of electrolysis of aqueous electrolytes, we consider two things. Because if it is aqueous, remember, that means we have two things, right? We have water and the what? And the electrolytes. So the electrolyte is here, electrolyte, which is what? Either X, Y. Do you understand now? You get. So in that case now, at the positive side, we have more than one electrolyte. Sorry, more than one ion. And this is have more than one ion. So what, let's say for example that we have H2 and XY. So at the positive side we have H plus, right? And then we have X plus. And then the next we have what? OH minus and what? Y minus. So in that case now, which one will be liberated? So that is that this scenario is the reason why in electrolysis of aqueous electrolytes there must be what? There must be a rule or a guidance or a sketch that helps us to know which of this ion will be liberated. So we call it what? Preferential discharge of ion. So why would an ion be discharged? Why would H plus be discharged, be liberated, and X plus not be liberated? Why would Y minus be liberated and OH minus be ignored? Why would X plus? So why would this guy be liberated and this one be left aside? Why would this one be liberated and this one be left aside? Now that is what we call what preferential discharge of ions. So which is what I'm about to do next. In that scenario, write it down in your notes, your pen, jot it down. Now, fast, boys. Jot it down, boys. About to off the board, huh? If you are here and you are a student of science, doesn't matter if you're engineering or whatever, you being in a biology class is to help your life. Now, biology is the study of life, and it's not about your department or your course. You just need to understand what goes on in your brain. You need to understand what goes on in your hormone. You need to understand why you wake up in the morning and then you feel as if everything is still cloudy. What makes you think you have a headache? I think ask yourself that question. Why is that when you're on TikTok and you're watching videos, you're watching anime or cartoon or movies or K-drama, your brain stays awake? But when you open your textbook, your destiny shifts. Why is that the day the dog is chasing you, is the day you know you're faster than the boot? And then you go, you disappeared. Have you asked yourself those reasons? Oh wait, where does sperm even come from? I don't understand. That's true. Where does sperm come from? Oh Jesus, how come you have hair on your head and some don't? Well, have you asked yourself, why is the bone of a baby soft? Oh my God. Do you know the meaning of skin and where skin get from? How does the skin respond to different messages at a time? Temperature, touch, hotness, pressure, and pain. All these things are in biology. So if you miss a biology class, you deserve to be shot right in the temple, right on your head. Not with a bullet to, I am not a criminal. Gotcha. Okay, so preferential design of a ion. Number one, we have position of a ion in the chemical series. Position of a ion in the chemical series. Position of a ion in the electrochemical series. Yes, this thing can determine, or this electrochemical series can determine if an ion will be discharged or not. Like when we have two or more ions, or when we have two ions and electrolyte doing electrolysis, it can determine which will be liberated. Number two, concentration of a ion. Concentration of a ion. Number three, nature of electrode. Nature of electrode. Now, after going through some past questions of UTME and IGZ, IGCSE, or IGNC, whatever they call it. After going through the past questions, I realized that most times questions doesn't come from molten angle. When a question comes from the molten angle, they would touch this nature of electrode. This nature of electrode is the most dicey aspect of electrolysis, or of electrolysis of aqueous electrolytes. Is the most dicey aspect. You have to be careful, very, very careful. So let's do this one first. Position of electrochemical series. Now, another name for electrochemical series is reactivity series. Another name for it is what? Is reactivity series. Another name is activity series itself. Now, what does this mean? Somebody said, well done, dude. Who is this person? Arushi Habi, 1526. Thank you for well doneing me. I brought an English from Nigeria dictionary. Somebody said to do mesh technology. Why should I do that? And then that message here that actually is related to my class. None. What is my just chatting here? Okay? I don't miss any message. Okay, let's go, guys, now. Are you ready? Let's put it out now. Nature of electrode is the most dicey, guys, here. So I said reactivity series. Now, what does this mean? I want to explain from this angle. You see, there's something about ions. There's something about ions. Some ions have a high tendency of, like, let's start with just one angle. Oh God, I feel like taking a screenshot of this thing. Jesus, I love my sketch. I say I love my sketch. I think let's do this now, right? Let's do this. Let's do this. So if you are here and you are not 100% focused, you shouldn't be here. Trust me, you shouldn't be here. Do you know why? Do you know why? Because you're wasting our time. Because you're supposed to here to learn. You're supposed to here to learn. Your phone or your laptop or your system should be on the right hand side. Should be on your left hand side. Then your pen should be on the right hand side. So get the hell out of my class if you don't want to learn. Because that is why I'm here. You ain't paying me, right? And YouTube is not even paying me either for now. So for now, the only way you can pay me is if you should watch this class, if you should be in this class, learn it, perfect it, understand it, and in your next exam, wherever you are, whether you're in Nigeria or Cote d'Ivoire or Ghana or India or Philippines, you'll be like, whoa, this guy was the reason why I'm passing this exam. So that is when I get paid. So if you're not here to learn, get the hell out of my class right now. If you're here to learn, welcome to Quantum Navigators Club. Do you understand? Good. Now let's smash this guy. So you see, the positive ions, aka the kappa ions, have a high tendency of getting electron. A very high tendency of what? Getting electron. While some have a low tendency, you can see, it's not long at all. Look at this one, very long. So it's not long at all, of getting electron. Now, which means in a scenario we have two different ions, like for example, we have Na plus and H plus. H plus tendency of getting electron, not H or H plus. Hydrogen will not gain electron except you want to form an hydride ion. Hydrogen mostly give out electron. Do you understand? So anyway, you see the word sodium, anyway, you see the suffix as hydride, it means in that case hydrogen is gaining electron. It's like sodium hydride. But in most cases it gives out. Like hydrogen sulfide. In that case, in that compound, hydrogen gave out 2 electrons to sulfur. 2 hydrogen give out 1 electron each to sulfur. You get? So now, but hydrogen plus does not. That one is to give electron out. But is to receive electron. Sorry. Here. Wait, guys. I think let me refill my marker. Did I have black marker? Oh Jesus, please! I don't have black marker. God. Oh shit. No black marker. Okay, so some cations have a high tendency. Oh God. Sorry, I want to change my marker. A moment, please. Oh. The person with the highest SP today is Abdul Malik. Second person is Daniel. Third person is Rosjane. Wow, man, that's beautiful. No, I'm not done actually. Don't worry. I will recap it all in a place. I'll recap the cation side. I'm not done with it. I'm trying to change my marker. Or refill my marker, sorry, it's a change. Yeah, I think it's over right now. So now, cation. So some cation has a higher tendency of gaining electron. Some other cation has a less or low tendency of gaining electron. You understand now? So sodium plus now has a low tendency of gaining electron, while hydrogen ion has a high tendency of gaining electron. In the sense that it means that Na plus and H plus are in these electrolytes, right? They went to the cathode to gain electron. Now, sodium plus, like for example, these 2 guys now, this is sodium plus, this is ion, hydrogen. These 2 guys now, there's a bond here, right? There is money here for them to pick. Right? This is sodium, this is hydrogen. Now, this guy has a less tendency of going to pick this money. And this guy has a high tendency of picking this money. But this one is a suffering guy. He is a fatalistic guy. This guy has gone through hell. He has suffered. Now, in that scenario now, out of these 2 guys, I want you to put in the comment section right now, out of these 2 guys, who will get to this money first? Is it sodium or hydrogen? Sodium that does not really need the money, or hydrogen that actually needs the money, that has a high tendency of getting the money. Who will pick it? Sodium or hydrogen? Type it right now, boys. Sodium or hydrogen? Hydrogen, thank you. Place is with me. Where again is with me? Where again is with me? Yes, we are all correct. Hydrogen has a higher tendency of accepting electron, of gaining electron, which means what? Hydrogen will be liberated, that means it will leave, while sodium will remain the electrolyte. That is how position of ion in the electronic series works. That's how it works. So same thing applies to the anion. Some anions have a very high tendency of what? Of losing electron, while some don't. So in this scenario, for example, Cl minus and and OH minus, or SO42 minus and OH minus. When these 2 guys meet, OH minus has a high tendency of losing electron than SO42 minus, which means what? OH minus will be liberated, SO42 minus will remain. So I think that is how Potential of ions works in electrochemical series, works for electrolysis of aqueous substance that are not concentrated or that does not have a concentrated halogen. You copy? So I'm going to give you, I think, the first 5 or 6 there about cations. I think number one there is potassium, we have K plus, Ca plus, Na plus, sorry, Ca2 plus, Na plus, I think Mg2 plus. How many people are there? I think after this one now we have probably should be around Al3 plus, zinc 2 plus, I think iron and then iron, then silicon, then this silicon. Silicon is a S, that's not silicon, that should be tin, and so on and so forth. Then the anode side, we have so I can't. It's just the same thing. The only difference is just that anions tendency of losing the electron, not gaining, unlike what is it called? Unlike cation, is the same thing. Just 2 lines of explanation. So in the negative side, we have NO3 minus, SO42 minus, Cl minus, Br minus. I think, yeah, if I'm correct though. So do you understand? Malala praise and what is it called? And Dockers, I minus, the Norwich minus. I think here we have, I think it's enough already. How many slides I want to give you? We have Al3 plus, we have zinc 2 plus, we have tin plus. No, I think iron first, iron 2 plus. We have tin and like that. So I think that's just for electrical series. So if I explain number 2 and number 3, now let's go to electrolysis. That's number 2, electrolysis now. So what are we doing? Next one. So we have done with number 2, right? We have done number 1, under preferential set of ions. We have done number 2, remaining 2 and 3. So let's go straight to what? Electrolysis of aqueous NaCl, or better still, let's do electrolysis of acidified water using Hoffman voltmeter. So that's number 2, electrolysis now. So I think let's do the last one. Electrolysis of acidified water. So in this case, we'll use aqueous H2SO4. Yes, this is what we'll use. Are we here? Should we do it now? I think the sketch, the way of what it looks like is something like this. Like this. Something like this. Yeah, I'm not artistic though. If you laugh, if you laugh nonsense laugh, then I catch you. Who is, let me even see this are laughing first. If I send them slap. And it goes down like this. Something like this. And it goes like this. And the battery is there. So we have the negative here, we have the positive here, and it goes like this. Also, the switch is outside, and like this. Yeah, something like this. This is where the sketch of Hoffman voltmeter is. I don't know. Well, I think this one sometimes will go up, then you have a switch somewhere here for the gas. So, but the board won't accept or won't easily cope, let's manage our board. So now, let's talk about acidified water, which is H2SO4 aqueous. So before we do, I think we use this place for the way we do the last one. We use this place. Now, going to be what happens at the anode, and then what happens at the cathode. All right? Are you there? Okay. So now, first of all, let's understand this thing here, right? That'll be, we have, since it's H2SO4 aqueous, we have aqueous. What's aqueous? H2O. So when we go to the anode, One will go to the cathode. So that's H2O and then H2SO4, right? So now the H2O in the anode is what? Well, if this guy is splitted, which ion from H2O will go to the anode, which is this the positive electrode, this is the negative electrode. So which ion will go is the OH minus over there. Then which one will go to the cathode? The H plus. Then for the H2SO4, which one will go to the anode? SO42 minus. Then the cathode, which one will be there? H plus. So in that case, like if you actually understand what we are doing here very well, you see that in the cathode, we don't have any issue of discharge of ions because it's the same. Right? But in the anode, we have an issue. And what's the issue here? In the anode, we have two different ions. And that's an issue. So which is one has to be chosen, or one has to be preferred to be discharged. One has to be preferred. Nevertheless, if you are doing aqueous of anything acid, in the cathode, you will always have positive ion. Are you with me? In the cathode, you always have what? Positive ion. Is there any message I've missed? Should be. That drawing I drew you earlier was just a simple sketch for Hoffman voltmeter, the electrolytic cell used for the electrolysis of acidified water. So most exams like asking that question in the objective angle, in the objective aspect. What's the mistake, Daniel? I'm actually on my phone now, so I can only see everybody's message. I'm not in the front of the screen, so I'm at the back currently. So you can talk, you can type your messages, and I can read them. Be fast, please, before I go back to the front. What's the mistake, please? I'm waiting. Okay, no message. Let's continue then. So back again, like I said, so the only agent that can actually be liberated here in the cathode, if not H plus, is what? Is H3O plus. And if you understand Arrhenius theory or Arrhenius definition of acid is a substance in which, when dissolved in water or when in aqueous solution, produces hydrogen ion or hydrozonium ion as its only positive ion. So this is the only ion again that could be from acid. Not from this one, no, from acid. This guy. If not H plus, it will what? H3O plus. Do you understand now? So in that case, they'll still give you the same thing. So there's no issue in the cathode. We have the same ion. Then the anode, the only anode we have issue. We have OH minus and SO42 minus. So which of them is important? Which of them is preferred to be discharged? It is OH minus. Why? Because OH minus is lower in the electrochemical series, which means he has a higher tendency of losing electron. So in the anode, what we're dealing with is what? OH minus, and that's what? OH minus will gain an electron. Sorry, we lose an electron. OH minus will what? Lose an electron. To make it easy now, anytime OH is one in the anode, oxygen is always liberated. So I'm going to be writing step by step, which of time it should become OH minus equals, or let's do it step by step. Would this please be enough? Now the OH minus equals to what? Normal OH plus what? Plus E minus. Meaning he has lost an electron, right? Then this OH cannot be liberated, of course, that's turn to oxygen. So to go like this from here to this place, that'll be OH plus OH equals to H2O plus oxygen gas. They balance the both sides, right? So one balance it out by what? 2 here, 2 here, plus here. So equals to what? 2 here. It's balanced now, right? So at the end of the day now, how many OH was used up? 4. So that's 4 OH. So when we use up 4 OH to give us what? Water, and then oxygen was liberated. Copy? So in that case now, let's go back here and make it whole. If you don't understand, I think you have to watch this place very slowly. You understand it. It's a very simple thing. OH here, OH ion here, loses electron and become OH. And become this OH. Right? Now this OH here combine with other OH. So we have 4 OH here that combine together to form water and oxygen gas. So this oxygen gas will be liberated at the what? Anode. So when this equation is a longer one, it's like if you're writing an exam that involves theory, that means I have to explain. This is how you write it out to make it clear and make your whoever is marking your examiner, whatever, make it give you your full mark. So these are you write it. You want to write it. So that was what? How many OH was used earlier? Remember it was four. Now will be four OH minus. We give what? H2O. How many H2O? Two. Plus how many oxygen? One. How many oxygen gas? One. Then how many electron? Four E minus. Is it balance? Yes. So this is what will happen at the anode. So this hydroxide ion, this OH minus, will give us water and oxygen gas, and then we'll lose what? Four electron. We'll lose four electron. So at the end of the day, at the anode, what happened at the anode is what? This guy here, which is the first thing, oxygen gas. Oxygen gas is what? Liberated. Oxygen gas is liberated. And number two, acidity increases. Yes, anytime oxygen is liberated in electrolysis of an acidified water, acidity will always increase. And because the reason is because as the O leaves, as the O reduces, because let's say we have, let me explain this thing with this place. Some of you are confused with this thing in your textbook. Why we have this thing here is what? Let's say we have 10 O, 10 oxygen, and then we have 10 hydrogen. And don't forget, what we know, hydrogen is the reason why we have acid. Do you understand? Or the highest concept of acid. Hydrogen is acid. So which means the more hydrogen we have, the lesser, so the higher the acidity. So let's say we have 10 O now, and then O was discharged. So we have like 5 O discharged. So we have 5 oxygen now, and then we have 10 hydrogen, which means what? The acidity is what? Higher. Simple. Do you understand? If you understand, please just type in the yes sir or drop your what is it called? Drop your favorite emoji so we can continue. Drop it there so we can continue, please. Do we understand, please? Do we understand? Yes or no? Okay, BJ, who again doesn't understand? I don't get that. Who again doesn't understand? Please. I'm trying to plug my phone, so I'm not at the front yet. But I'm coming back soon. I'm trying to find a way to plug my phone. Okay, guys, before we continue our class, let's share dinner. So, how many of you are interested in eating bread? So we can share, but hopefully the bread is not our last supper though. Why is it not charging? Okay, it's charging now. That's Aeneas theory. Aeneas theory. That's what I'm saying. All this way is not Aeneas theory. Aeneas theory is Aeneas theory. Come and drink malt here. Thank you so much for giving me malt. So, hello everyone. Let's go for a short break. Let's eat bread. Yes, I bought this is electrolysis bread. I'm actually marketing top this. I'm giving them free adverts. Okay, hi. Yeah, so let's go to a short break. Don't leave the YouTube channel. But I actually need to like start chewing something. Do you know why? Because my blood deserves some glucose. I'm lacking. My brain is already starving of food. Dudu is dead. No, that's true. I was just gonna get a drink, but I got home very late. So actually, when I started the live class, I was just inside. I have to even use some scope and then go to bait. I was baiting what the live class was going on. Yeah, I able to pass the bread through the phone. Yes, 100%. If you want that. So yeah, now I've washed my hands. It's time to actually start chewing some stuff. Sir, you only slide me. I know you. Okay, I don't actually understand what you mean. My network. Oh Jesus God. Okay, everybody, let's let's know what the brain. Yeah, I'll pass the bread, please. Open your Bluetooth. Kindly open your Bluetooth and let's hear the first supper, not the last supper. Yeah, yeah. I think my body deserves to eat. My brain is hot. You smoke? Mm. Yes. I've got the electrolysis on the bread. Yeah, right. I'm left. Lots of bread. um, lots of bread electron. I agree. Okay, guys. I think I'm almost done my meal. Bread electrolytes. You don't know? Okay, guys. Now I think I'm back. Let's continue. Now, what happens at the cathode now? So we are done with this, right? Everybody understand this, right? So what happens at the cathode? Since there's no any competition, hydrogen will be liberated, right? Will be discharged. So let's do it. Now that will be H plus. Now don't forget, 4 electron was lost in the anode. So it means 4 electron will be gained in the cathode. Is a must. It is a what? A must. The number of electron lost here, the number of electron that will be gained here. If you lost 8 here, 8 will be gained here. So that will be H plus 4 plus what? 4E minus equals to what? H2. That's the equation. Now be 4 here, 2 here. So now, how many mole of oxygen gas? Let me write it here. So hydrogen gas is liberated. Acidity decreases. I already explained this, right? That if oxygen is removed, then acidity increases. But if hydrogen is removed, acidity decreases. So now, first question of the day under this now is this. Tell me in a ratio, that means anode ratio, cathode. How many moles of oxygen was liberated? Is it 5, 4, 3, 2, or 1? How many hydrogen was liberated? So write it in the ratio. Tell me, how many oxygen was liberated in the anode? How many hydrogen was liberated in the cathode? ASAP. It's on the board. Write it now. How many hydrogen was liberated in the anode? How many hydrogen was liberated in the cathode? Sorry. How many oxygen is liberated in the anode? How many hydrogen is liberated in the cathode? The nano is the anode. Please just ignore. Okay, I've seen your own. Carry on. I've seen your own VJ. Wait again. I've seen their own. In ratio format, please. Daniel, I've seen your own. Abdul Malik, Apayami. All over place. I've seen it. Was James Wycliffe. Okay, that's correct. So, we're done with this one. But 2. We're done with it. Now, let's go to number 3. Electrolysis of what? Aqueous NaCl. I'm going to the board. Write this down in your notes. I'm not top of the board. Now, the answer is, for some of you that are watching this stuff, I don't understand. The answer is 1 mole of oxygen gas, because there's nothing here, is 1. Is liberated at the anode. Then 2 moles, which is this 2 moles of cathode. 2 moles of hydrogen gas in the cathode. So, that's all. Now let me ask another question now. How about you can try to give me the net equation or the full reaction on the board of what we just did? How about you can give me the overall effect or the full reaction of the net equation? You're eating the bread alone. No, I'm not. Oh. I've given BG of the overall reaction on the electrolyte. That'll be 2H2 equals to what? 2H2 plus what? O2. It's simple, don't worry. So I think that's the next one we're doing now is electrolysis of what? Of aqueous sodium chloride. Well, we'll do two versions. Are you ready? So I've done number one, which is what? Position of ion in the electrochemical series. I've done this one. Let's do number two now, which is what? Some can say relative concentration or concentration of what? Of ion. Now, this is what I want to do next now. In this case now, this one works with some special electrolytes. Let me put it here for you so you can jot it down because it might not be in a textbook. It moderately works with electrolytes that has halogens. That's just it. Anything that involve halogen, concentration will be a staking power, or will be a concern, or will be of concern. So which means an electron does not. That means first of all, the electron has to be what? Has to be number one. Has to be aqueous. After is aqueous, the electron has to be what? Halogens. Or have to contain halogen. Have to contain an halogen. So when the electron is aqueous and contain halogen, then this number two will be of concern. Then lastly, when the electrolyte is also concentrated, because aqueous, we have two aqueous. We have two aqueous. Aqueous can be equal to what? Can be equal to dilute, and aqueous can be what? Can be concentrated. Sorry. So when the aqueous is concentrated, one, the aqueous is not containing an halogen. That's all. But let's say it again from the beginning now. So the only time we use this number two, this preferential discharge of ions, whereby relative concentration of ion is of concern, is when number one, the electrolyte is what? Aqueous, one. The electrolyte is concentrated, two. The salt is a salt of halogen, meaning compound contains halogen, three. When these three things are marked, that means this guy will be of concern. Do you understand? I'm making it very, very simple for you guys. Do you understand? Please, I want a response. Do you understand what I just explained just now? Hello? Okay, I'm going to continue. Okay, thank you, Rose Jane. Seems I don't know with me. Thank you. Another person. Oh, Jesus told me, say, I already doesn't understand. Oh, Allah praise. Oh, Jesus, a lot of people don't understand. Well, let's do it again. Now, you know, we have three things that, let's do it again. We have three things, or let's say, when we have more than one ion, more than one similar ion in an electrolyte, that means on the positive side, we have like two different ions. Let's say in the positive side, we have Na plus, we have H plus, that's different. Or on the negative side, we have Cl minus and OH minus, that's different. So when that arises, we have something we call preferential discharge of ions. That means the reason why some ions will be discharged, that means they will leave or they will be liberated, and other ions will not be liberated. The first thing that can influence it is what? Position of ion in the electrochemical series. And we did that one. We used an example of electrolysis of acidified water. right? Electrolysis of classified water, which is H2SO4, aqueous H2SO4. And in that electrolysis we just did earlier, in the anode we have we have SO4 2 minus from the acid, and we have OH minus from the water. And at the end of the day, OH minus was liberated because OH minus was the one we deal with because it's lower in the Tonga series. Long story cut short. Whereas there's another second one, which is what? Relative concentration of a ion. I'm not explaining to you when should you not use this, or when would this not work? When this will not work, that you have to use this one to check which of this ion will be liberated is one. Number one, the electrolyte has to be aqueous. That's one. It's not molten. It is aqueous. One. Number two, the aqueous solution has to be concentrated, not dilute. It has to be what? Concentrated. Then lastly, the aqueous solution has to be a salt of an halogen or is a compound that contains halogen. Do you understand now? Yes or no? Do you understand now? Welcome, Oluwatobiloba. Please, I need a response or I'll continue. Do we understand now? Okay, somebody has responded. Okay, good. Another person? Okay, good. Let's go. Okay, then. Now that's the mean. So, because the thing is, what about electrolysis is that it's like genetics and organic chemistry. The terms just appear confusing. So, maybe it's just, no matter how long the question is, what did Nelson say? No matter how long the question is, what did he say? He said what? First of all, let's say the electrolytes. Oh, they said aqueous, concentrated, blah, 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 blah. Maybe you see aqueous, one, concentrated, two, and then the compound contains halogen. They say chloride, iodide, bromide. When you see those three things, just like, okay, number two ni ọ̀gádé kí ló ṣẹlẹ̀ number two na we go use. Do you understand now? So now, and then it must be concentrated. So if you understand this, let's do one electrolysis now. So next one we do is electrolysis of, we are doing two though, but the first one we do today is electrolysis. Where's my doorstone? Oh God, they have stolen my doorstone. Somebody have stolen my doorstone. Okay, so we're going to do two electrolysis now, and I'm going to use these two but at the same time so that you guys can understand easy peasy. So we're going to do electrolysis of dilute aqueous NaCl and electrolysis of what? Of concentrated NaCl. Then mine is only asking that question on Tuesday and I answer the person. Let me answer it again. Concentrated aqueous NaCl is the one that is called brine. So if you see the question says brine. Just know that what? They are talking about what? Aqueous. We're talking about concentrated sodium chloride solution. Now let's do it now. So we want to do one here. So electrolysis of what? Electrolysis of number one, dilute NaCl solution. I want to do dilute NaCl. So that means dilute sodium chloride solution or aqueous sodium chloride. Then number two, we'll do what? Concentrated NaCl solution, which is also known as what? Which is also known as brine. Also known as brine. Don't forget, though. So if they don't put what you call that, they should write down brine. Just so that's what I'm talking about. I'm talking about what? Concentrated NaCl. So let's do the two now. So for the two now, let's bring it out. So we have, since both of them contain water, so we have it as this. We have the anode here, and we have the cathode. Here too we have anode. Here too we have what? Cathode. So then here we have H2O. Here we have NaCl. Here too we have H2O. Here we have NaCl. So in the H2O now, what will be in the anode? OH minus. What will be in the cathode? H plus. What will be in the anode? Cl minus. What will be in the cathode? Na plus. Here too, same thing. OH minus, H plus, Cl minus, Na plus. So these are over there. First level. So which means in that case now, something will happen at the anode. This will not be too small. I think I'll manage it. Something will happen at the anode. Something will happen at the what? Cathode. So here too the same thing. Something will happen at the anode. Something will happen at the what? Cathode. So for the electrolysis of dilute NaCl, let's do some first now. Let me see if we are still there. Are we still there? Are we still there? Who is all in one? All in one, welcome. Stupid gamer, please sleep. What is this person typing? I'm sure this person is not an African. Was that person type like an abandoned Tinubu? I always see that Brian very well. Yes, when you see Brian Abdul Malik, Brian is concentrated NaCl, but solution. I mean NaCl with the inside water, we consider conk. NaCl with the inside water, we consider conk. Now be what? Concentrated NaCl equals to brine. So then that's why I said sometimes the exams can be very simple, but the fact that people that only pass some exams, say especially option based objective based exams like UTME now, which most of you are preparing for, there are two kind of people. So number one, those who they already studied and understand or understood. That's one. Then number two, they have solved enough questions. So then I won't say they don't work hard because I'm also one of the one student actually passed UTME. But at the same time, luck still shine on us. And then questions or a bulk of the questions came from what we studied. So just suppose we have studied before, just click. Because naturally, maybe if the question that asks, I already explained just that. Okay, what if the electrolyte is aqueous? That one is concentrated to and contain halogen. Then you what? This is the way to work. But then you don't see this one. You just saw brine. That brine has already destabilized. You don't even know where to start from. You get that. So sometimes these points are very important. Phosphor. Do you understand? Phosphor is just an alloy. You get something here, or even bronze. What's bronze? What's brass? But we're not there today. Let's continue what we're doing. So I'm not spread the class 10. And the anode now, for dilute NaCl or for a dilute electrolyte that contain halogen, what will we choose here? Well, that in this place, H plus will be liberated or H plus will be discharged. So in this one, what will be liberated? Cl minus is dilute. OH minus is dilute. That means they're both weak. So according to the electrochemical series, OH minus will be what? Discharged because it's lower in the electrochemical series. Bam. This one is dilute. This one is dilute. All right. So this one will be discharged. So what happened at the anode for this guy here is what? And that is what OH minus now. That will be the same thing again. OH minus, that is 4 OH minus equals to beta still equals to 2H2O plus O2 plus 4E minus. Is it balanced? Yes. This is what happens in the anode. Which at the end of the day, this is all liberated. O2, oxygen gas. Are we following? Just like what happened at the in the acidified water. And don't forget that I told you, the metal acidity is liberated. What happened? Oh, that means acidity what increases. Right? Are we following? Now, what happened in the cathode? Since this is what we liberated, that will what? 4 electron is important. So that will be H plus equals to sorry. H plus plus 4E minus equals to 2H2 4. So which means it's all liberated in the cathode. So which means just like we did in the acid in the what is it called? Just like we did in the acidified water. So that means first thing first, 1 mole of oxygen gas is liberated, then acidity what? Acidity increases. Then here 2 mole, right? This is 2 mole of hydrogen gas is liberated, then what? Acidity what? Decreases. Then this is how it will happen for the dilute NaCl. Now what will happen in the concentrated NaCl is completely different from this one. Number one, concentration. I'm going to explain this before I start solving. Concentration does not deal with cations. That's one. Write it down. Concentration does not deal with cations. Write it down right now. Concentration does not deal with cations. Concentration effect is not applicable towards cations. It is only limited to halogens alone. It's only what? Limited to what? Halogens alone. Are you there? This is very, very important too. So anytime you see the word concentrated, LAO, nothing concerned with what? Concerned with cations. And what does that also? It does this concentration does also what affect oxyanions. That means it does not affect ions like this. Ions like NO3 minus, SO4. It does not affect them. It only affects what? Only halogens. SO42 minus. So for that reason now, this guy is conk. This guy is conk. But how do we concentrate now? We both know, we all know that what chlorine ion is not the most concentrated ion out there. So for that reason, unlike this one, chlorine ion was liberated. Remember the two things. Concentration does not affect cations. One, does not affect oxyanions like these two. It only affects halogens. So in this case now, halogen is more concentrated than this guy. So Cl minus will be liberated instead of OH minus. So what here is what? Cl minus, which is equal to what? Well, let me use blue here. So it's a balance. So Cl minus, which is equal to what? Equals to Cl plus E minus. That'll be Cl2 here, right? Cl2. So balance it 2 here. And then what? 2 here. So which means at the end of the day, what happened? So in this case now, there's not like acidity increases or acidity decreases because oxygen was not tampered with. I don't know if you're getting the point. Is there a question? Why is Na plus not with this of? Because in this case, I don't say just now. In this case, you are actually in this cation now. Concentration does not affect cations. That does not affect positive ion. So what you will use here is what? You will use POI. What's POI? Position of ion in the chemical series. So how is it COI? You are using what? POI. You're not using COI. You're using what? POI. So in POI, H plus is lower in the electrochemical series. So Na plus will be liberated. Do you get my point? H plus is lower, so Na plus was liberated. That's the point. But COI affects ions that are halogens. So in that case, this guy will be liberated because it's considered than what? Than OH minus. Then the cathode now, H plus will be liberated. So that's H plus how many electrons here? 2. 2E minus equals to what? 2 equals to H2. So these are all liberated, these are all liberated, and these are all liberated. So now you see that the results of these two guys are different. In the dilute electrolysis of NaCl, in the electrolysis of dilute NaCl, what happened there is what? Is 1 mole of oxygen gas is liberated at the anode, and then acidity what? Increases. 2 moles of hydrogen gas is liberated, and acidity what? Decreases. Whereas that same NaCl, concentrated version of it, what happened in the anode is what? 1 mole of Cl2 was liberated. While the cathode, 1 mole of hydrogen gas was liberated. Do you understand now? This is actually clear, it's actually calm. Or 1 volume, I don't know how to say it. Is it clear now? Are we there? Is it clear? Hey, what's up, people? Is it clear? Is it getting better? I need a response, please. If you're actually still with me. Okay, you can see the responses now. Okay. More responses, please. Okay, kind of. What happened, Ganu? For those dropping emoji, thank you. Okay. Okay. The POI part. The POI means position of ion. POI means position of ion. COI means concentration of ion. That's the meaning of the two of them. So before we finish today's class, So in next class we'll do pure calculation. Today's class, let's do the last one, which is nature of electrode. How does the third one affect? We have done the first, which is what POI. POI affects just basically what is it called? Electrolysis of substances that are mostly there's no issue of constitution or not. That's one of POI affects. Are we good? Are we good? So let's do the last one for today now. Nature of electrodes. So you can just please down, look at this sketch. Ha! Okay, can I off the board now? So now, like I said, I don't know. I feel like I felt like not rubbing off this thing. I like the way the thing is designed. I swear, so designed. If you actually follow me in this class, you see, you understand this thing on the board is like exactly. I love that. We're gonna be storming YouTube very soon. I swear. I say YouTube, TikTok very soon. Like look at this thing very well. If you actually look at it very deep, you understand that this explains almost everything in electrolysis. Like except that part of COI. There are two different electrolytes here. In this electrolyte here, COI does not work. POI works. In this electrolyte here, COI work. Hello, class. Let me even check the comment section here. Let me check the comment section here so I can actually leave my phone behind. Me turning upside down is not good for my health. If I can collapse. Okay, I want to be able to see your comment section. So actually, let's take a short break and actually talk a bit. Let's take a short break and talk a bit. Okay, now. You're not serious, please. Okay, let's talk a bit now. Now let's talk now. I think you have. So as I was saying, any other message, Adejoken wrote me. I don't understand what you mean by no, so Aki wrote me. I don't understand what you mean. Okay, so let's take it now. So like I said, these two electrolyte here. Okay, everyone here, I want you to do something for me. Take a screenshot of this and post it again on status. Let them feel it. Let them feel it. Hello, take a screenshot of this, post it on your status. Let them know that quantum navigators are doing some crazy shit here. Do you understand? Take it now, boys. I'm gonna drop my own screenshot on the status on the channel now. You can share the one on my channel too. This is Nelson Learning Space. Hashtag I show science. You don't want to miss it for real. Should I continue? Somebody asked earlier that what class is this? This is electrolysis in chemistry. Electrolysis in chemistry. Okay, so I just need to just like, take a short break. So allow you guys to assimilate what I've done a bit. And then we'll actually machine ahead. To see if there's any new message. I'm back. So I think everyone should be back already too. Exam Jesus. X man extra 6'5", whatever. I'm a student of 10th grade level. Hello everyone. Yeah, hello, you're welcome. You're welcome. Are you a science student? That's the first one. Yeah, 10th grade. Are you a science student? If you're a science oriented student, this is chemistry. I'm currently doing electrolysis. I don't know if you say someone should have answered them. Okay, so let's continue, right? I mean, if you are here, don't share the thing to your status. Go to the WhatsApp channel now and share it on your status, boys. Share it to your status. Let's let them know that something is going on. At least we should actually let them know that we are serious with our life now, eh? Share it to your status, boys. That's the only way you can actually pay me back. You're not paying anything, you're not doing any shit. So don't. Okay, I can see one here. I see one person post it already. I can see another person here. Yeah, I'm liking your status already. Oh, I see a lot. I see a lot. I see quite a lot. Quite a lot. Okay, I can see it. This is great. Oh, there's another one here. Wow, I can see it. I can see. I'm gonna like everybody's one. If I go back to class. You guys are the reason why I'm here. I can see another one here. It won't cost you anything for real. I mean, some of you are actually bunch of only God understand for you. I mean, you just hear, you can share good news. Yeah, we're navigators for you, boy. We're navigators. I see that. I see. I search you. Okay, I think I've liked every little one that I need to like. These are the important people. All of you are important. All of you are the real navigators of the navigators. Okay, so back to base one now. I think I've rested enough. Yep, yep. Oh, geez, beautiful. This is beautiful. Okay, let's continue then. Oh, Jesus. So let's go to the last one. Nature of electrode. Okay, are you ready? Now let's do nature of electrode right now. So nature of electrode. So I've done number one, which is what? Position of ion. That's POI. We have done it. Position of ion. There's number two, which is what? Concentration of ion. I've done number three, which is what? So I'm about to do number three, which is nature of electrode. Nature of electrode. Now, so the first one is position of ion. We have done it. As meaning this. So I'm about to do this one now. So what does this mean? Before we start giving an example, let me check my comment section. Before I start giving an example now of when can nature of electrode applies, the first thing I want you to understand is this. See these three guys, they work hand in hand. That's the first thing. But it's just like some overpower some. Like in a situation where we have a dilute Cl and OH minus. We know OH minus will come out because POI works in that case. And POI give reference to OH because OH is what? Is lower in the chemical series. In the case where we have, this is dilute, right? In the case where we have concentrated Br and OH. Is that a message or something? Oh, okay. In the place where we have concentrated what? Br and OH. What does that simply mean? Br will be what will be preferred. Because yes, OH is actually lesser. There is POI. OH is lesser than the chemical series. I said whoever is more concentrated, whoever that means write this down. POI is equals to, if you are high, you what? You remain, you stay. If you are low, you leave. COI, if you are high, you what? You leave. If you are low, you what? You stay. If you are weak, or better still, you can say, instead of using high, you can say what? If you are strong, you leave. If you are weak, you stay. And in this case, bromine ion is a more concentrated ion than what? OH ion or hydrogen ion. So for that reason, Br will stay. So that's just it. Now, but when can these two keep quiet and then this one will work? When? That is when you have to understand the three types of electrode. So we're going to be going to what? The types of electrode. Number one, we have the the passive electrode. Let's start with passive. We have the passive electrode. We have the what? The passive electrode. So types of electrode now. There are three. We have number one, passive. Let me see this message. Write it down, please. Number one, passive. Are you there? Number two, active. And number three, mercury. I'm going to explain each and every one of them now. Number one is what? Passive electrodes. Some books can call it, let me even use the whole space. Some books or different textbooks can give me different name, but just know that it all means the same thing. So another name for it is passive or inert or active. No, not active. Yeah, active. Is it active or not active? No. Inert. I prefer inert. Inert. So number two is what? Active electrode or active metals. I said I'll explain each and every one of them right now. So number two, active. And number three, mercury. So let's say we can just call it what? PAM. So there are three types of electrode, which is what? PAM. Passive, inactive. Inactive electrode. Then we have active, not electrode now. In this case, we have two types of electrode. We have the anode and we have the what? So active electrode now, the electrode that are used at the what? At the anode. So I know you wonder why did Mr. Nelson change from from green to blue? I know my reason. So passive electrode, active electrode, mercury electrode, but we use them differently. I get to my point. We use them what? Differently. So the first one is what? Passive, or can be inert, or can be what? Active. Oh Jesus. Are we there? Should I continue? Okay, no message. Now, but then mercury is now what? Electrode, but is at the what? At the cathode. Are you saying? So Palm now, this guy named Palm is what? EAC. Share you they see. Share you copy. We get what? Palm, where we what? EAC. But share you they see. Write it down. Palm, share you they see. EAC. Now, so I'm gonna explain each one. Are you ready? Now, this is the most common one. This guy, I need to get more markers. All my markers, all the other markers, my amount is already faulty. Markers of less than 3 weeks. Fake things in this society. Let's go. Now, how do you do this now? Let's break this boy down. You see, this one is the most common one. This guy here is the most common one. How do they work? Passive means they don't react. Like, wait, let me get some. Baby shadow, baby shadow. Hello, please don't tell anyone that I took the plate. Actually, that's why I borrowed the plate. You see, don't tell anyone. If you tell someone, I'll not give you guys again. I think it's time for me to sit down. Please, let me sit down. And can you see me? Someone come and check. Now, if you can see me, just say yes, we can see you. So I want to sit down and explain. Can you see me? Can you respond, please? Can you see me? Hello, can you guys see me? Hello, can you see me? Be fast, please. Can you guys see me? Hello. Can you? So I want to sit down and talk. What's going on? Is it network? Okay, I'm going to continue now. If you can see me, good. If you can't, I think I can't stop. Now look at, so this guy is an electrolyte now. And we have two passive electrode. So one is here, one is here. Let me check it from here. Let me see if you can see me. Okay, where's YouTube? So that's, as in me sitting down here, can you guys see me? So I can know that you guys are seeing my explanation. Oh, good. Thank you. If you can see me there, that's beautiful. Oh, testimony. Asimi. I hope I pronounce your name very well. Welcome, testimony. Emmanuel. Oh, Chuku. Yeah, I don't want to spell the name. Thank you for being here. So, Clef, my man. Thank you for being here. I actually don't know that person though, but the person is still my man. So I want to also check it for me so that I'll be sure. Oh yeah, this phone is not responding. XR is already getting hot. Okay, let's do it now. So we have an electrolyte now, and these two guys are passive electrode. So this side now we have the anode here, we have the cathode here. Now when they are passive, it means obviously I explained on Tuesday that when electrolyte is going, when electricity is going on, electricity is just simply just using electricity to cause a chemical change, right? A chemical change. And I give you as a good example. That what is it called? Chlorine ion is what? Chlorine ion is blue, right? But copper is was it colorless or something? I can't remember again. My head is already spinning. So there will be a chemical change. Or a very good example is like silver. Like silver ion is what? Is basically like how I put it. Silver is silvery, while silver ion is more of colorless. Do you understand now? So now for you to form silver ion from silver, it means silver has to gain an electron. That's a chemical change already. So now we have the passive two electrode now, two passive electrode, right? We have two passive electrode. So they don't affect the electrolytes. They don't join in the electrolytes. They're just there. They don't do anything to the electrolytes. So this kind of electrodes are called passive electrode. E.g., they're majorly two, or basically two, or not only two, but majorly two, which is mostly platinum and graphite, carbon. No carbon, right? Another type of carbon is graphite. Or you can use I don't know if you notice that your battery, your Tiger battery, there's one small thing in between it, in the middle. That one small black thing like this. That is an electrode. Yeah, it's an electrode. That black thing. That's gotten from a kind of that's the graphite or thereabout. Or you can use charcoal. Charcoal is also an another type of carbon if it will be stable, if it will stand strong. So those kind of electrode are called what? Passive electrode. They don't affect the electrolytes. They don't dissolve the electrolytes. They don't add anything or remove anything to the electrolytes. And eventually what? Two, which is what? Mostly what? Platinum and graphite. Do you understand now? That's for passive or inactive electrode. And number two, active electrode. Now the active electrode now is basically always at the anode. So this is the anode here. So the active electrode does not affect this place. So I'm going to drop this one here. I'll drop it. So the active electrode is basically here, somewhere here. Now how does the active electrode work? The active electrode is like this. You know, in the anode now, in the anode, remember that in the anode, what goes to the anode is negative ions. So an active electrode first, I think I need to stand now. So for example now, sorry, I'm trying to check if this okay, we play. So I'll see if there's messages or I think it's answering me now. So for example now, let's say you are doing electrolysis of a salt. Let's say for example, copper sulfate. Copper sulfate is a salt, right? Containing a metal and an oxygen ion, right? Now, if this metal happens to be the electrode at the anode, so this is the anode, right? So this is the cathode. So if you this is not playing, no. It's not playing, no. Let me see. Can you guys see me? Hey, Jesus. Oh, hello. What I'm explaining is, hope you guys heard that. Somebody put 100%. What does that mean? Is it yes or no? Hope you guys heard all that I've been explaining all this while. Oh, okay. Hello. Why are you guys responding late this time around? Is it network or something? Okay, good. Thank you. Because this second phone is actually bleeding. So now let's say we have one electrode at the anode and another electrode at the cathode. So we are dealing with these salts, right? Now, if you use the metal of these salts as the anode, in that case now the anode becomes what? The electrode becomes what? Active. So in a very simple line, when you use the metal of the salt that you are dealing with as your electrode, it becomes what? An active anode. Let me say it slowly again. When you use the metal of the salt you are dealing with, so it might not be serious, it might even be something like this. It might be zinc. Let's say zinc nitrate. So zinc no3 2. Let's say something like this. Or I even use aluminium. Let's say aluminium Al2. No, is it Al2? Al2 SO43. Now I do something like this, and you now use aluminium. You use this aluminium here as your electrode. You use aluminium as an electrode. Now it now become what? Active anode. It means that this guy will participate in the electrolysis. So you use something like this zinc. You use like this copper. Now in that case, when you do such thing, you know what will happen at the anode. Let me know the board. So it means that at the anode, let's say for example, I dealing with what is it called? Copper sulfate now. And what you use as your electrode is copper. You now use copper as an electrode. Copper as an electrode. It means what will happen is this. At the anode, instead of SO4 going to the anode, no, it will not go. This guy, SO4 will not go to the anode. What will happen is anode itself will now dissolve. Anode, which is copper, right? Now anode is copper. So copper what will dissolve. Copper will dissolve. So that is why you don't use an active anode except you want copper. So same thing applies to, let's say you are dealing with zinc. So let's say I'm dealing with zinc nitrate or aluminum sulfate. I'm dealing with aluminum sulfate. So I deal with aluminum sulfate. We now went ahead to use what? Aluminum as an electrode. So which means at the anode now, unless I zinc aluminum nitrate gone. Or I'm not hydroxide. I also do something else, something else, which is OH minus OH3. So we now use aluminum as your anode now. So no matter what we learned, they need to COI or POI. So the anode, you know OH wants to come to the anode. And if OH comes to the anode, the limited is what? Is oxygen. So instead of that, no, that will not happen. Since you use aluminum as your anode, aluminum will what? Dissolve. Aluminum will what? Dissolve. So in that case, what will just happen at the anode is just basically what? Aluminum gaining mass. Kò for active electrode. Do we understand? Do we understand? So that's what will happen. So that is how active electrode works. So if you want to write, you can write this little down. So for active electrode, write if you want to write. When a metal, excluding platinum, because platinum is a passive electrode, platinum is a passive electrode. So the only electrode that is electrode from carbon, right? Which is graphite. Yes, so okay, thank God Malik got it. Malik is not hard, right? Look at just put this sketch in your head, for example. Put this sketch in your head. Put these two examples I give you in your head. That okay, you use the metal, these two metals, you use them for your electrode, meaning you use in the anode, you use at the what? You use at the cathode. At the cathode. Use here too at the anode and at the cathode. So instead of we know that yes, copper will go to the anode, cathode, sulfate will go to the anode. Here, I don't go to the cathode, then oxygen, hydrogen will go to the anode. So that will not happen. That will not what happen because you are using an active electrode. This thing will not happen. This one will happen, yes. This one will happen. This one will happen, yes, correct. But this one will not happen. This blue one will not happen. No, it will never happen because you're using an active electrode. And when you're using an active electrode, the metal of that metal in that anode will dissolve. So what just happened here for copper is Cu become what? Cu you now get an electron plus 2e minus. No. You should use electron, not get. So now become Cu equals to Cu 2 plus E minus. That's what will happen. Sorry, plus 2E minus. That's what will happen in the anode. So instead of SO4 coming, so Cu equals to Cu2 plus 2E minus. That's what will happen. But instead of this one coming, to come and do SO4. SO4 2 minus to give us SO4 plus 2E minus. So instead of this one happening, this is what will happen. This one will happen. This one will not happen. Unlike the normal POI and COI that will let. And then this one too, same thing will happen here. AL will give us AL3 plus 3E minus. Then here what? Instead of OH minus coming here, which is basically 4, to give us H2O plus 2H2O plus O2 plus 4E minus. So this is what will happen. This one will happen, this AL will happen, this one will not happen. Because you're using an active electrode. That's exactly what it means. Do we understand, please? Do we understand? Do you understand? So that's just exactly why I just draw the board now. That's exactly what will happen. So because it is active electrode. So which means the same way you saw the question, and the question mentioned aqueous, mentioned whatever. So which means this thing, active electrode only work with anode. Only work with what? Anode. So it's like that time. Now only with the anode there is a metallic anode, a active metal in the anode. So that one that we talk about COI only work with halogens, aqueous, and concentrated. So if you understand this one now, let's now move to the third type of electrode, which is mercury. Mercury as cathode. For now, talk about electricity of some substance. And then other will close today. Not to write this down. Not to write. Right. When the metal is used as the anode, and the electrolyte is a sort of that metal, the metal will what? It's already on the board will dissolve into the what? Solution. And I don't know if they will ask you, but it's possible. Let me explain to you why this may happen. You see, SO4 minus will lose electron. Cu plus will lose electron. Al here will lose electron. OH will lose electron. See, the things I'm teaching in this class is not about joke. I'm giving you punch lines that you will not easily notice them except you actually listen to me. Is that a set in class if the teacher is actually good in the subject? But you might not even hear. or your eyes will not see it in this book. Now, if you have been asked, which of course, question like this will only come out in basically A level chemistry exams. Now, I'm not saying you tell me last. If you tell me ask, you said you know for why? You say a navigator, you're a quantum navigator, and quantum navigators they know the four. They are kill navigators. You get the copy now. So why will this one happen? Where's that my second marker? Oh, okay. Why would this one happen, but this one not happen? Why? There's a reason. Because they are both losing electron. But the energy required for this aluminium to lose electron is lesser than the energy required for this anion to lose electron. All I want to say now, I'm going to cut this clip out and post it on my status. That's like very funny. Let me even see. How many people are actually active now? If you're active, I want me to say what I want to say now, right? Exactly. Navigators know they panic. Navigators know they panic. We go find them, we go see them. We are navigating. So anywhere the money is, we will see it. Anywhere the success is, we go see them. Anywhere where that's where we want. Anywhere where they we go see them. We are navigators. Okay, so boys, I don't know what to say now. Just type it and said, be quiet. If you're with me, if I can see like 6 or 7 be quiet, I'll go ahead. Type it there, be quiet. I want to give you a scope now. Be quiet. Type it, be quiet, and I'll tell you the scope. Be quiet. I'll tell you the scope that makes this guy this guy choose over this. I'll tell you the scope. I've seen one. Yeah. Mom, let me just see. Be quiet. I said be quiet. You say I'm active. Active call. I've seen how many quiets now? I've seen 1, 2, 3. It's not enough. It's not enough. It's not enough. I want more. Be quiet. I've seen. Bring more. Bring more. Let me see how many active. Be quiet. Type it there. Be quiet. Okay, Alex. Let me tell you the shit now. This is actually funny. I don't know. I want to sit down. Can you guys see me? Wait. When I sat down, were you guys seeing me when I sat down? Malik, were you guys seeing me when I sat down? Were you seeing me very well? Was it clear? Malik or BJ, some of you have been here for okay, good. Let me sit then. So now let me say something. So I want to give you guys the gist. So I want to compare this copper ion, copper, not this copper ion, copper aluminium versus sulfate ion and hydrogen ion. Yeah, this hydrogen ion, sorry. Now you see, if you're actually a student of mine, you have taught in a physical class, I must have tell you this, right? We want to explain why this is preferred when you're using active electrode and this is not preferred. So I told you about 2 different guys. I told you about female and male. Hello, this is just a joke, though. So I told you about women receive, or girls, not women now. Girls receive, they collect, they take. Your younger sisters, your girlfriends, even your mom. God bless our mother anywhere they are. God bless us, and so we can bless them. So women receive. So if anytime a woman give you something, be very careful. Like, how far, babe? Why you give me this thing? Do you understand? So women don't easily give. Like your girlfriend or your sister can have 50K in her account and still call you for 1,000 airtime. Now, why men are designed to give? So as a man, may God bless you so you can give to your younger sisters, your other sisters, your mom, your girlfriend, the female friends that the real ones. So men are designed to give. Now, the energy, like for example, now you don't want to receive from 2 guys. You want to receive. So 2 people now, they want to both lose. This guy here, he is a lady. So Josie or somebody was a lady. For example, let's use CL minus. It was a lady before, just a normal lady, that received and become only basic. So let me ask you now, have you ever seen that you give your sister or you borrow your mom 5K and then you are able to collect that 5K back? Oh yeah, now how far you now? You borrow your mom 5K, are able to collect the 5K back. It is what impossible. She'll start narrating to you all the story of how you eat under her, how she breastfeed you, she'll give you rules and Hello, I'm here. Don't worry, I've seen it. How far long is mic off? Hello, for how long has mic went off? So I don't even know how long I've been explaining, not knowing that this guy is not actually on again. For how long? Yeah, I know. Can you? Oh Jesus. Okay, so where did I stop in the definition in my story? It seems they don't want me to say the story. Where did I stop? So that means you guys know about the Buhari part. Do you hear about the Buhari part? Do you hear about the Buhari part? When they don't give up. Oh. Okay. I think I get that point. That was towards the end. Then that means it's not even been long before I noticed it. Also, that's great. Yeah. Okay. You started a new mic, so it's alright. You're back. You're back on the ground. Yeah. Back. The Buhari parts now. Don't worry. I will Buhari parts. For those of you that called me, I already see. Okay, it's alright. It's alright. Okay, so it's alright. No shit. No shit, huh? I'm gonna explain it now. They're back. So the mic, I've fixed the mic. That mic even tried. I don't even know the percentage of it before it went off. So it's alright. We're back. Thank you. Okay, we're back. Right? We're back, huh? Okay, good. Where's my markers? Oh, beautiful. Okay. Yeah. So now, where I stop, I said, how easy is it to collect what is it called to collect that factor from your mom? Extremely very hard, right? Now, so I don't get this to example. I said, this is oxygen here. Let's say this oxygen here is your girlfriend. So oxygen was actually, in fact, you see this two that oxygen got. Oxygen received it from you. So you gave oxygen 2K and it become what? Only base, which is 2 minus. So 2 minus on the oxygen head means that oxygen has received from you. Now I'm going to ask you a question now. So you put on the comment section. Huh? You put in the comment section. Out of receiving 2K from the oxygen you gave 2K before in the past and receiving 2K from Buhari, which is a male friend. So who is more easier? Is it oxygen, your female friend, that you gave 2K before, or Buhari that you have never given 2K before? Who is more easy to collect 2K from? Type in the comment section. Buhari or oxygen? Buhari or oxygen? Who guys? I'm waiting. So is it Buhari that is more easy to collect 2K from, which is your boyfriend, or oxygen? The male friend, oh, this one saying none. Oh, no, that means now you now people on your side with them. Oh, no, do she? Okay, I said I've seen your own. Somebody clef. We're gonna say, tell me, Buhari or your male friend? Okay, I've seen another one. Buhari, right? Let's see more. Who is it Buhari, your male friend, or oxygen, your female friend? Who can you collect 2K from? Oh yeah, now guys, drop your comments. Be fast. Let's make this interesting. The male friend, of course. Yeah, copy. Put it up. More. I want more answers, boys. I want more answers. Just choose. Is it your male friend or female friend? Remember that even your female friend, you have given her 2K before. It's not as if she has received 2K from me before. But now you want to collect 2K back. Who is more easier? The male friend. And let's stop there. Now, what does this mean? It means if by any means not even collect 2K from this girl hand, you use all the scope in this world, babe or Aburomi. Don't worry now. I'm expecting one money from Tokalabi. She won't send like 5M, you understand? So if you give me this 2K now, you see that 5M, I will come dash you like 500K from there. You see that XR, which you want buy. From there, I don't go buy you XR. I'll buy you 13 Pro Max, better camera, like 90% battery life. Forget it, Joe. Let me I did for you. You will lie all the lies in this world before you give you that 2K.
So these two guys, this is your girlfriend and this is your male friend, the man, male, man, that's it. Male and metal, M male, M metal, they both give. Non-metal meaning not male. And what is not male is FE male, meaning FE is not male. That's not call them what you call them iron male. So women are what? Iron male. Do you understand? That's like they are not male, they are iron male. So they're what? They're cargo, they're caco, they are, they lady pa, they will do you bad. Women, even your sisters, when it comes to if you call us like I will be come and football for me, she can run. I will be come and for sure, she will come and do it for you. Come and dish share, she will dish share. When it comes to I will be or my babe, come and give me money, she will lady pa, they are iron male. Do you copy? Marine girls, I swear. Who say big lies? Who if I bought you say big lies? Who say I say real boat na womanizer? So I say men never disappoint, always asking to give. Oh, real boat say female friend. That guy, check am well, check am well, check am well. That guy na silicon. You know what silicon? Silicon na what? Na metalloid. They are male and female. So that guy na what? See, if your guy is living like that, don't call them gay. They're not gay, they're not lesbian, they're not womanizer. They are what? Silicon. And silicon way is a conny like the word CS silicon. It's a conny way. Oh, okay, God. Okay, boys, now let's go. So they get it now. So the energy, I'm not joking, no. This I should explain it. That's the way it works here also. The energy required for a metal to lose electron is lesser than the energy required for an anion, that is a negative ion or a non-metal with a negative ion to lose electron. So we prefer aluminum losing electron and copper losing electron. That's the meaning. That's the reason. That's the meaning. So I think we are done with that aspect. So I believe that this short story I tell you now, in the future, wherever you find yourself, and this question, in fact, go to school tomorrow. When you go to school tomorrow or tutorial tomorrow, show this question to somebody. Show it, let the person fall. Like, best I have for a guy, 5K. Oh, they must say. Like, that person will fall. But the person know and check your money, let me tell you. Oh, sorry. So in that case, now the last one that is very for us to learn, other types of electrode is mercury. Now there's something about mercury here. Mercury is just like that one is not actually crucial, but it's still necessary for you to know. You see, let me come to the comment section. You see, mercury is for cathode now. He said, if you know, I'm starting to go pay. They play, she never see. Robot na silicon. Robot is about silicon. Oh, okay, yeah, boys, let's go now. Now, so we said, let me use this place. Let's share the board. Active, passive. Passive is electrode, meaning both A and C, other than cathode. And what's passive electrode? They don't interfere in electrolytes. Example, platinum and graphite. Overton, that's number one. Number two, active electrode. Active electrode is just for only A. And what does it mean? It means metal will what? Metal will what? Will dissolve. E.g., copper in copper salt, aluminium in aluminium salt. Overton. And number three is mercury. Remember that is what is like this. PAM, PAM, which means what? PAM is EAC. So PAM with a C, meaning passive is what? Electrode, A and C. Active is electrode of anode. Mercury is what? Electrode of what? Cathode. Now you see, this is for example, let's say you do electrolysis of NaCl now, you do electrolysis of aqueous NaCl as Na plus H plus. If these two guys meet, in most cases now, H will be liberated. But then, if at this cathode side, you now use mercury, you use what? Mercury as your cathode. This is cathode, negative. You use mercury. What happens is H will not be liberated because hydrogen gas, hydrogen gas has a very high voltage and it will always react with mercury. You understand? That's what reacts. In this case now, sodium will be liberated. In a simple line, when mercury is used as a cathode, and hydrogen is in the cathode, the metal will mostly be, the other metal, either sodium or potassium, will mostly be liberated. Is it correct? Is it correct? Do you understand? So, normally, when any, let me say it again, when Na plus and H plus meet, H plus will be liberated normally. But if mercury is used as a cathode, H plus will not be liberated because anything gas has a what? High voltage. So in that case, Na plus will be liberated. Na plus will be liberated preferentially or in preference will be liberated. Do you understand, please? So we can move to the last electrolysis of today, which is electrolysis of um, copper sulfate solution using copper electrode. Do you understand, please? I need response so we can continue. Ah, how many of us had issue with network when I was explaining mercury? So I'll explain it again. So our last class of electrolysis was calculation under electrolysis. When we learn the two calculations under electrolysis, and that will where electrolysis will end for this class. How many of you did not understand? I don't understand. Oh, okay, sorry. Now, mercury is the easiest, so I actually don't have issues if you don't understand it. I will explain it again. Okay, let me explain it again. Mercury is the easiest. If network was issue, let's say it again. If you're actually doing it for the first time, or you start doing it for the first time, if you're doing us newly, you might really not understand because I've explained this one already. Now, look at we're not dealing with cathode, right? Not anode like active, and not anode and cathode like passive, only cathode. Because in the cathode, this is cathode electrode now, negative electrode, right? Now, if a negative electrode is what the electrode is not platinum, is not graphite, and it is mercury, something will happen. Now, in the cathode, now let's say you have H plus and Na plus. Let me see if you're following me. You have these two ions in the cathode, which one will be liberated if mercury was not used? Type that in the comment section. Which one will be liberated if mercury was not used in cathode, I mean H plus and Na plus? Yeah, answer me please. If you have hydrogen ion and sodium ion, which one will be liberated? Okay, I've seen your answer, BJ. Malik, I've seen your answer. Oh, Olale is the correct one because the way you write is correct. Good, Ade is correct. Who is H plus? Your H is even small letter, BJ. Olóòdo rẹ̀bàtà ojú ẹja ló mọ̀ ọ́ jẹ́ òní ṣe pépà ilé tí ìlú ọ̀hún alámìkílò gbà kànbọ́lọ́ ìbàdàn. Okay, Emmanuel write HWWE. It's all right. I see your own real good. Fikaya, I see your own. Okay, that's good. That means all of us understand this. That's normal. But if mercury was used as the electrode, H plus will not be liberated because H plus, which is hydrogen gas, right, will react with what? With mercury, or will just go to mercury. So in that case now, what will be liberated, unlike other electrode, if you use mercury as an electrode, what will be liberated is what? Is Na plus. In simple line, when mercury is used as a cathode, hydrogen will not be liberated. The other metals will be liberated, e.g. Na plus. That's the meaning. Do you understand now? If yes, say yes. If no, say no. You understand now? Okay, I've seen like how many years now? I've seen three. Okay, another more years. Do you understand now? So I'll be dropping some PDFs on the WhatsApp channel and on the YouTube, or preferably I'll drop the PDF on well either WhatsApp channel or the Facebook page. Anyone, I'll drop the PDF so you have access to more details. It's only for sodium. No, 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 no. It's only for hydrogen, which means if K was the one I was here, let's say K is the one that is here, K plus is here now, and normally the same thing will happen. H is supposed to be liberated according to POI. What's POI? Position of a ion in electrochemical series. That's POI. But this H will not be liberated if what we have as a cathode is mercury. If Ca plus is also here, same thing, sorry, Ca2 plus, same thing will happen. If it's Mg2 plus, same thing will happen. As long as you're using mercury, H will go there. So let me see. Let me see the question again. I've answered their own. Please, another person. Another person. Okay, that's okay then. That's okay. So one last electrolysis we do today before we close is electrolysis of copper sulfate. And the reason why I'm doing it is because just to understand how this nature of electrode works, right? So let's do the last electrolysis before we go for today. Don't forget, please. I'm not saying you should actually share us, but I mean, I know you have friends. Huh? I know you have friends. I know you have people that want to become mechanical engineer, electrical engineer, medicine and surgery. I'm studying medicine and surgery. I'm studying nursing science. I want to be a nurse. I want to be a doctor. And they actually need chemistry, biology, physics. I mean, I don't know. I may not be the best of the best, but I trust myself. I trust my capability. I'll show you what I'm capable of. As from tomorrow, share the stories. I'm not saying share the link. Like intentionally tell them, oh, you're even doing a video like, hi guys, it's one of the maddest places I've ever known that chemistry and biology is easy or physics is easy. Just go to that guy's name. The guy is Nelson. And I'm not saying you should pay for class. Let's go to my free class, which is on YouTube and on TikTok, my WhatsApp channel and my Facebook page. Those places I'll be sharing you PDF, content, text, videos that will help your life in academics. You understand? I mean, tell them. I want us to be massive. So by the end of this year, I want us to be at least 1,000 key navigators across Africa. The 1,000 is very, very small though. I mean, the real ones. You copy? Good. Let's do now. So now, BJ, Abdul Malik, Emmanuel, Testimony, Fikayo, Small Boy Clef, Rose Jane, whoever is there again, I don't mention your name. Now, if you're actually here, now let me explain something to you. Now, how do you know when to consider electrolysis? Anytime the question mentions the electrode, trust me, there's a problem. Because in most cases, they all say electrolysis of acidified BJ. That means if that's where you stop, it means that the electrode is what? Passive, is inactive. But when they say electrolysis of acidified BJ using the problem. When I say using, make sure you consider that electrode. But let's start and say, electrolysis of aqueous olale place. So the just that is dilute. But if it's not dilute, I'll tell you electrolysis of what? Concentrated aqueous olale or electrolysis of what? Concentrated olale place solution. So be mindful of the question. Do you understand? Be mindful of the question, the way the question pops up. You get. So now, I think, like I said, last one we're doing today is the electrolysis of what? Of copper 2 3006 solution. Using copper electrode. Let me see. How many people have we see here? Secret. Who says secrets? Emmanuel. That name is hard to pronounce. That Igbo name is concentrated dilute. Okay, let's do the last one, boys. So that will be electrolysis. That's my what? We have done molten NaCl. We have done acidified water. We have done concentrated NaCl solution. We have done. So this is number 5. Number 5. Electrolysis of CuSO4 solution. CuSO4 aqueous solution using copper as electrode. Using copper electrodes. Now you see that now I'm using copper electrode. It means these are not inactive 1 and these are not mercury. So this is copper 2 tetrasulfate 6. It's a salt, right? So what happens is let's come back here first. Since an aqueous, it will contain water and copper, right? So that means let's have water first. So we have anode here, we have cat here. So let's have CSO4 here. So in the water side, we have OH minus, then we have SO4 2 minus. In the cathode side, we have what? H plus, or we have Cu2 plus, right? You copy? And in that case now, so right here, we're going to be learning 2 things. Here, let's say here, something will happen at the anode. Let's say something happened here at the anode. And here, something happened at the cathode. Now, what will happen at the anode? There are 2 guys. Is either OH is discharge, or SO4 2 minus is discharge, right? Let me see comment section. So in the anode, is that OH minus is discharged, or copper 2 ion is what? Discharged, or what's other thing that can happen again? Or the copper itself dissolves. And that's what will happen because in the anode, the copper is the electrode. So that's what will happen. So what happened at the anode is this. The copper, see, I'm actually checking you guys' message if there's any message, but I'm not, it's not loading yet. I'm at the phone now. You can ask any question. Want to ask question, please. Okay, no question. Yes, let's continue. So there are two things. There are three things that will happen there. Is that, like I said, the what is it? Okay, so this is that hydrogen ion is discharged, or sulfate ion is discharged, or copper electrode dissolves. Now what happened? This is what will happen. Copper electrode what? Dissolve. Which means that the anode, copper will dissolve and become what? Ion. What happens is Cu equals to what? That means it will gain electron. But you know, sorry, it will lose electron. But you know what happened in the anode is what? Oxidation, right? Don't forget to is anox. Anox and cat red. What happened in the cat is what? Reduction. Don't forget. And what's oxidation? Oxidation is what? Oil, which is what? Loss of electron. And what's reduction? Reduction is what? Weak, which is what? Gain of electron. So copper, because copper will lose electron, that will be equals to Cu2 plus 2E minus. In that case, what happened at the anode? Two something. Number one, copper dissolve. In bracket, copper loses ion, copper loses electron to form what? To form ion. Then number two, what happened again is that what? The anode, the mass of the anode, or the mass of the anode increases. Mass of the anode increases. That's what happened. That's what happened. These are the two that happened. Let me go to comment section now. Do you understand, please? Do you understand what else happened there? Wait, oh, what I just read. Decreases that he lost electron. Sorry. It decreased, no, it lost electron, not gain. It lost electron, so it will decrease. Copper mass of anode decreases. Do you understand? Who say, what's the point again? I've not just explained it just now. What's the point again? What's the point? Why don't you understand? I can't see any message. I've explained this thing because we use copper electrodes, and the copper that we use as electrode is also the salt, so which means it's an active electrode. And what will happen when an active electrode is the anode? It means that what one of them like waited that same anode will dissolve, meaning that same metal will lose electron. This copper, it lost electron and become what? Copper 2 plus. So nothing is discharged or liberated in the anode. Rather, just that the mass of the anode decreases. Question? The board writing is not clear. Sorry, what is timing? Manage. Zoom it, Emmanuel. Zoom it. Zoom. I don't want to tamper with what is it called with the board. Almost done with the class. So I'm not ready to start stretching myself again. So is it clear now a bit? Can you manage it, Emmanuel? Please, don't ask questions. I'm actually at the back of the phone now, so I can see your messages. So drop them be fast, so I can actually wrap up. This one can't zoom on. Is I cannot see it or you don't understand? Let me write it again. So what happened at the anode is that copper dissolves, which means you lose electrons, which is Cu equals to Cu2 plus 2E minus. And what does this mean now? It means that number one, what happened at the anode is number one, copper dissolves. Copper dissolves. The copper anode dissolves, which means copper loses. I don't know if it's correct. Is it loses or lost? Copper lost 2 electrons. Let's use lost. Copper lost 2 electrons. Or copper lost 2 electrons. Or lost electrons to form what? To form ions. You don't need to signify these numbers. Just write lost electrons to form ions. Then number two, for losing ion, the copper, because it's not copper itself. It's not this copper that loses. It's not this copper. Oh. It's the copper anode. So number two, what? The mass of anode decreases. Because while losing those two electrons, the mass of the anode decreases. Now is it clear now? So is it okay now? No, so do you understand now? I want to go to the cathode. What happened at the cathode? So I'm going to drop, remember to remind me and make sure you share it to your friends that are actually in the class too, that are not in the channel yet. I'm going to drop a PDF, maximum 24 hours from now, probably by Friday evening, that will show you, electrolysis of different substances, the electrode they use, what is it called, the electrode they use, the products that will be formed at the cathode or the anode. So, and then you will see effect of electrolysis, whether concentration will increase, whether concentration will increase or concentration will decrease, so you understand. So do you understand now? Okay, good. I've seen many years now. Where is Rosine? Rosine, so I've said yes. That's great. Let's continue. So what about the cathode now? Remember that we have H plus and we have Cu2 plus. Now in these two scenarios, now this is what happened. In these two scenarios, H plus is lower in the chemical series, right? They play. Cu2 plus is lower, not H plus. Cu2 plus is lower in the chemical series. So which means, according to POI, remember, right? To POI, who is high will stay, who is low will leave. So H is high, is above Cu2 plus. So H will stay, then Cu will leave. So Cu will be liberated. So now what happens is Cu2 plus we gain electron, that's plus 2E minus give us Cu solid. Right? That's balanced. Now if you look at it very well, so electron was lost here. So electron was gained here. Now in the comment section, tell me correctly what happened at the cathode. There are two things that happened at the cathode. Let me see if you guys are actually on fire today. So in the comment section, tell me what happened at the cathode. Two things that I've told you what happened at the cathode. Number one, copper lost 2 electrons or lost electrons, or copper dissolves to form a ion. Anyone you say. That copper dissolves to form ions. Sorry, not copper anode, not copper. Copper anode dissolve to form ions, or copper lost electrons to form a ion. Copper anode lost electrons to form a ion. Number two, the mass of the cathode decreases. So what happened at the anode and the cathode? I'm waiting. I'm waiting. I'm waiting. Okay. What happened at the copper is deposited? Hey, Jesus, see answer. So do well. Okay, somebody said, let me, another place, gives electron. No, that's not the right word now. Abba. In fact, in this place, if I want to make it very correctly, do you know what you say here? You say copper anode dissolve to form ions. This one, these things are added. It's just for you to understand. This thing are added just for you to understand. In the view sense, what happened in the anode is what? The copper anode dissolve to form ions. Because when you say copper itself, people go, where is copper from? You understand now? So what happened at the cathode? Let me read some answers first before I write my own. I'll see some answers. Mass of cathode increase. Oyibo re. Number two, I saw the position of copper. Mass of cathode increase. Mass of Okay, well, you're actually correct. Number one is mass of cathode increases, and the copper is deposited as a cathode. Let me write it there. Let me use blue. So first thing first, copper is liberated or copper is deposited. Like, wait. Vi said. Now tell me, what's the color of copper metal? What's the color of copper metal? Type it out, boys. What's the color of copper metal? I don't understand. The copper is in the job, okay? You are saying something else, Roseanne. You have covered it too. Hello, what's the color of copper? Wrong, BJ. Wrong. Wait again. Don't use AI now. Why you guys? You have, all of it. So, some of you are not leaving the video, which means you are not here. BJ, wrong. Yeah, that means you are 1 minute to go and check Meta AI or ChatGPT. Gray. Ah, no. Wrong. Roseanne. Wait again. Reddish brown. Ah, wait, but no, wrong. I'll not accept that one. Okay, final answer. The answer is brown. So let us waste time again. I'm actually a bit exhausted. Copper is considered as a what? As or at the as a brown shiny metal at the cathode. At the cathode. So let me correct it now. For blue, BJ, copper ion is blue. Copper ion is one that is blue. But copper itself is brown. Silver ion, colorless. Silver itself is more like silver, like that's the color, silver. You understand? So number one, copper is deposited as a brown shiny metal at the cathode. Number two, mass of cathode increases. Then mind you, nothing actually changed overall because the blue nature of this guy, copper matter is blue. If you divide this into two, you see Cu 2 plus and SO4 2 minus. You divide into two. So the overall effect of this guy, nothing actually changes because as this guy, as copper here is turning to copper ion here is turning to copper. It's as if it's a cycle. So as this one is losing, this one is gaining. So nothing changed. So the blue remains the blue. So now do the electrolysis of this guy, the blue remains. So overall effects, nothing changes. Yes, sir, nothing changes. So I think that's just the answer. Wait to Jesus, there's a question here. So this is reddish orange. Don't say reddish orange. All I praise, I'm going to copy it. Oh, my Clef, you want to go and copy it, I'm very, very sure. Green care. It is not green, no, I don't know. Go and check which metal is that too. Even when it loses electron, it's not green, it will be blue, not green. Copper is blue. The only metal I know is that is green, that's iron. So I actually have to go and check that research to know why it's green or something of liberty. I don't know if it's actually green or something. I don't know. But copper iron is blue. It's appearing green, but it's made of copper and it's not painted. Have you been there? Have you, have you been there? Have you seen State of Liberty Total? Have you seen it? Wait, let people see the SP. Who has the SP today? Malik is the highest. Whoa! Rose J, second highest SP. Whoa! Wow. BJ, third highest SP. Ganil. Whoa. BC Zobi. Okay. Okay, guys, I think we're going to close right now. Our next chemistry class, which is next week. Oshijino. Probably next week Thursday or next week Tuesday. I used to read facts. I know. I've heard of that thing before also. I've heard of it about copper, blah, blah, blah. But there needs to be an explanation that I don't know. And I've never been interested in it. I know. I've also actually come across that line whereby they say copper lose electron, that's why the state of liberty is green or whatever. I know. But I've never been interested. That's why I just ignored it. So you actually know. I know what you're saying. That's the guy in New York now. What is not increasing? Whoa, wheelboats. I don't know why it's not increasing. Let me see. Let me check you out. Let me check why it's not increasing. Wheelboats, let me see. Let me find you. You're not even in top. Wait, that's true. You're not there. Oh. Something is wrong then. Probably have offended YouTube. You're not there. Probably, or probably you did not open or I don't even know why. I don't know why. Let me just say that way. I don't know. I'm not actually what is it called? Hey, my navigators will choose, but it has to be either Tuesday or Thursday. It can't be Sunday because this Saturday is biology, this Sunday is physics. They play VJ. So yeah, I'm Rose Jane. It has to be. I don't know. I don't know. I don't have idea of the day to be, but I just know this Saturday is biology, this Sunday is physics, next week Tuesday. Depending on what we probably then probably yeah probably to be chemistry then. But depending on what we do on Sunday on in physics, if whatever we do on Sunday in physics is not did not exceed that day, then it will be on Tuesday. But if what we do on Tuesday, if what we did on on Sunday for physics exceed that Saturday that Sunday, then we'll be doing it on Thursday or Sunday. So yes, so our next and last bus stop for electrolysis is calculation of electrolysis. And this is going to explain all the electrolysis of different substance and how each and every one connects and how each and every one work. Thank you so much for being here with me. It's nice having you guys. Welcome to Nelson Learning Space, the space where navigators not only learn but succeed in all their endeavors. We are Q navigators. We always get what we want. Cheers. Older ball. Bye bye. You don't do math, Rara. Which one is math? Mathematical. Yoruba name. How do you do English? Yeah, hashtag I show science. I love that. Yeah, that's the biggest hashtag right now. Hashtag I show science. Bye bye.